For 6 million years, humans have walked the Earth, looking up at the stars, assuming the universe is going to patiently wait around for us to explore it. It won't. Look closely at our home. It feels permanent. But in the 14 billion year timeline of the cosmos, a 4.5 billion year old Earth is a temporary arrangement of rocks and water. The first unyielding deadline comes from our own star. In exactly 1 billion years, the hydrogen-helium fusion reactor at the center of the sun will increase its luminosity by 10%. That minor bump in brightness pushes Earth's average surface temperature past 47 degrees Celsius. The oceans will boil away entirely, trapping carbon dioxide in a runaway greenhouse effect that leaves the planet sterile. This animated scale diagram shows the secondary deadline. After burning through its core fuel, the sun swells into a red giant, its expanding radius aggressively sweeping through and consuming the orbital paths of Mercury, Venus, and eventually Earth. To outlive the star that birthed us, humanity has to take direct control of the solar system's orbital mechanics. Survival requires turning the entire solar system into a massive interstellar spacecraft and steering it out of the danger zone. We do this by building a Shkadov thruster. Picture a spherical mirror, 250 times thinner than a human hair, but millions of kilometers wide, suspended directly over the pole of our star. By bouncing half the sun's photons back into the star, we create an asymmetrical thrust, pushing our solar system forward. Simultaneously, magnetic fields siphon off streams of hydrogen and helium. This star-lifting technique starves the sun's mass, keeping it a stable red dwarf. Even with these controls, the sun's habitable zone will move. To avoid incineration, we will need to tow Earth's orbit out into the darkness, dropping our planet into a new path near the rings of Saturn. Mastering our local sun provides a stable sanctuary for billions of years, buying us the time required to face the larger instability approaching from the wider galaxy. 4 billion years from now, that massive collection of stars on the horizon, the Andromeda galaxy, is going to smash into the Milky Way. Direct stellar collisions are rare. The true threat is the intense cascade of exploding supernovas and gamma radiation sweeping across the merging star fields. Humanity will have to use its stellar engines to physically pilot our solar system out into the quiet fringes of the galaxy, waiting there until the two massive bodies settle into a single elliptical structure. By physically steering our solar system to avoid the wreckage of the collision, humanity proves it can manipulate gravitational physics to ensure its own persistence across multiple galactic eras. But deep time holds an inescapable math problem. Fast forward 100 billion years, and the universe's expansion will push neighboring galaxies completely out of sight. Inside our isolated bubble, the final stars will burn out. With the starlight gone, maintaining billions of lives requires a massive energy pivot. We either upload human consciousness into digital frameworks or build a habitat around the absolute extremes of gravity. This necessitates the final architectural triumph of a highly advanced civilization, the Birch Planet. Rather than orbiting a star, this colossal metallic shell is constructed to encapsulate the supermassive black hole at the center of the galaxy. This visualization shows the capacity. By tapping the black hole's energy, the Birch Planet maintains an Earth-like gravity capable of housing 10 to the power of 30 people. This structure supports a population so massive that our current global headcount disappears into the rounding error. By domesticating a black hole, humanity bypasses the death of normal stars, securing a fortified habitat that will last for trillions of years. Pushing into this timeline demands a break from what we currently consider a natural human existence. We started as a species subject to the weather on a single rock. To make it to the end of time, we have to learn how to manipulate the most dangerous objects in the universe. We stop being passive observers. Instead, we physically bind celestial bodies with artificial geometry, steering the cosmos exactly where we need it to go. By surviving this planetary infancy, humanity creates the possibility of outlasting the stars themselves, maintaining a home until the very last black hole in the universe finally fades away.